We're heading back to the moon, and this time, the goal is to stay there for good. That's the mission that NASA, the US government, and many international and private partners have committed to. If everything goes according to plan, this won't just be another moon landing. Getting people there is still a challenge, but it's something we've managed before. What's truly new and ambitious is what comes after we land. The next big step is to start building. We're talking about setting up a long-term base, basically a small town on the moon's surface. No one knows exactly how it's going to play out, but we do have some smart and practical ideas for living away from Earth. But before we get into that, the first question is, where exactly will this moon base go? The moon is huge, and all past missions with astronauts landed near the middle, in flat and safe areas that had a direct connection to Earth for radio signals. That was back in the 1960s. This time, the plan is to explore a much more exciting area, the moon's south pole. This part of the moon is full of deep craters, high mountains, and ancient volcanoes. Some parts, like the bottom of craters, never see sunlight. They've been in shadow for millions or even billions of years. Scientists believe these dark spots are filled with ice brought in by comets and asteroids over time. NASA has picked 13 possible landing areas for the Artemis missions. These spots are mostly on sunny ridges or mountaintops surrounded by rough ground and deep shadows. It's an incredible place for science, but it's also full of risks for the astronauts who will be living and working there for long stretches. To make this work, we'll need to build systems and structures like nothing we've ever done before. Everything that supports life on Earth, power, shelter, transport, will need to be recreated in a place that's cold, dry, and completely unforgiving. So where do we start? With roads. That's right. We'll need paths, landing zones, and firm surfaces to work and build on. But there's a big problem: moon dust. The surface of the moon is covered in a thin but very soft and powdery layer of dust made up of tiny, sharp particles. This dust is so rough, it can damage spacesuits and scratch the helmets astronauts wear. On top of that, it sticks to everything. During Apollo missions, dust built up on the moon buggy's radiator, making it overheat. And because the moon has no air and weak gravity, once this dust is kicked up, it floats and spreads far. When Apollo 12 landed, they tried to touch down near an old probe called Surveyor 3, which had been there for a few years. What they saw showed just how far moon dust can travel when disturbed. NASA wanted astronauts to check on the old Surveyor probe, and what they discovered was surprising. Even though the Apollo lander had touched down about 180 meters away, the force from its rocket engines had kicked up so much dust that it blasted the surface of Surveyor like sandpaper.
So if we plan to build a base on the moon with people landing, taking off, driving, and walking around regularly, we'll need to seriously reduce the amount of dust being kicked up. That means building roads, landing zones, and strong surfaces around the base to keep the dust under control. One quick fix that could work for now is something known informally as rhino snot. It's a spray used by the US military to harden loose dirt and sand, especially for creating temporary roads or helicopter pads. It became well known in places like Afghanistan for turning soft desert ground into firm, usable surfaces. It was especially good at preventing huge clouds of dust during helicopter takeoffs and landings. So while it could work on the moon at first, it's not a great long-term answer. That's because we'd have to bring all that material from Earth, and using it would mean covering the moon in artificial chemicals, basically microplastics, which isn't ideal. A more lasting and eco-friendly solution would be to actually melt the moon's surface into solid glass. That's what the European Space Agency is testing in a project called PAVER. Scientists are using fake moon dust and strong lasers to see if they can turn the powdery surface into a smooth, glass-like layer. The idea isn't completely new. People once thought about paving desert roads here on Earth by melting sand all the way back in 1933. That didn't work out back then, but on the moon it could finally make sense. After all, glass is just melted sand. The good news is we might not need to carry heavy lasers to the moon. Instead, we could use focused sunlight. One way to do that is with a special kind of flat lens called a Fresnel lens. These lenses focus light using ridges on flat plastic, making them lighter and easier to pack than traditional curved glass. To do the job, the lens wouldn't need to be huge, just a little over 2 meters wide. But there's a catch. The moon's south pole has low sunlight angles and long shadows, so we might still need lasers to help. No matter how we do it, this method would take time. The scientists working on PAVER think it would take about 115 days to create a landing pad 100 square meters wide and 2 centimeters thick. That's roughly 100 times slower than building roads with regular asphalt on Earth. Even so, it's a crucial step. We'll be spending a lot of time driving on the moon. The main way people will get around is inside pressurized vehicles like the lunar cruiser being developed by Japan's space agency and Toyota. These rovers will let astronauts travel across the surface without having to keep putting on and taking off their spacesuits. On the moon, astronauts won't be walking outside between buildings the way we do on Earth. Instead, they'll move straight from their pressurized living space into a pressurized vehicle and then into the next pressurized area. This setup isn't just for safety, it's how we'll explore faraway parts of the lunar surface. One of the main vehicles planned for this is the lunar cruiser, which is basically a space version of an RV.
It's designed to support 2 astronauts on trips lasting up to a month or even longer, using hydrogen fuel cells for power. But having a moon RV is just one part of the plan. We also need places to live. Our housing on the moon will be built in phases, starting with temporary shelters and then moving to more permanent buildings. NASA has already come up with a design for our first moon home. It's called the Foundation Surface Habitat. This habitat has 3 levels. It mixes a solid metal structure with an inflatable section, and it's built to support 4 astronauts for up to 30 days. In practice, only 2 people will likely stay in the habitat at a time, while the other 2 are out exploring in the lunar cruiser. The bottom level is made of metal and is about 4 meters wide. It holds the airlock, space suits for going outside, and a small science lab where astronauts can study rocks and soil from the moon. To reach the second level, astronauts climb a ladder. This part is inflatable and expands to about 6.5 meters wide. The middle floor is where the crew will have access to basic hygiene tools and workout equipment. It also has a small biology lab to study how lunar conditions affect plants and animals. The top level is the main living area where astronauts will sleep, cook, relax, and take care of their health. It includes beds, a small kitchen, a workstation, and a medical area. There's even a space dedicated to studying how living on the moon affects the human body over time. Once the initial living phase is successful, the next step is building long-lasting structures that can handle the harsh conditions of the moon. This means creating shelters that can protect against dangerous space radiation, extreme temperature changes between day and night, and even small meteorite impacts. To make this possible, we go back to one of the oldest building methods known to humans, using bricks. Just like researchers are exploring how to melt the moon's surface to make glass roads, they're also testing ways to bake lunar dust into bricks for construction. The idea is to keep using metal or inflatable habitats, but surround them with a brick shell. This extra layer would act as insulation, helping control the inside temperature and offer better protection from radiation and debris. China has already started working on this concept. They've designed a rounded structure called the Moon Pot Vessel. Their plan is to use robots to build it, combining ancient Chinese construction techniques with modern technology like 3D printing. The bricks would be made directly from lunar soil. In 2024, China kicked off a project to make bricks using 5 different types of artificial moon soil. They tested 3 different ways to heat and harden the soil into solid blocks. Later that year, in November, these bricks were sent to the Tiangong space station and placed outside on a special rack. Over the next 3 years, they'll be exposed to space, including vacuum, radiation, and extreme temperature changes to see how tough they really are. Another bold idea involves combining glassmaking with building structures on the moon by shaping huge glass spheres.
It sounds futuristic, but a US company named Skyports is exploring it with support from NASA's Institute for Advanced Concepts. Their method is similar to traditional glass blowing, just on a much bigger scale.
The process starts by heating moon dust until it turns into a thick, melted liquid. Then, by using compressed gas, they inflate it into a large bubble. Because there's no air and low gravity on the moon, the bubble can grow huge without collapsing. For extra strength and insulation, they could even make multiple layers of glass with air spaces in between, kind of like double or triple glazed windows. It might not be the most realistic plan, but it's definitely a creative one. Still, no matter how we build with bricks, glass, or anything else, we can't do any of it without a reliable source of energy. So where will we get power from? The obvious answer is the sun. Solar panels have powered most moon missions so far, and they've done the job. But there's a major issue. The moon spins much slower than Earth. That means it experiences about 14 days of sunlight, followed by 14 days of darkness. This hasn't been a big deal for short missions where astronauts only stayed for a few days. But for robots or rovers using solar energy, they only function during those 2 weeks of light. After that, they freeze during the long night, and many never restart even when the sun comes back. If they do turn on again, they usually don't work as well. Now take a look at the 13 possible landing zones for NASA's Artemis missions. Most of them are in areas that never get any sunlight at all, deep in shadows. But those are also the places where we're most likely to find frozen water, which is essential for survival and building a moon base. That's why the future of energy on the moon might be nuclear. Using nuclear power in space isn't a new idea. China has already been running a nuclear-powered rover on the far side of the moon. NASA has used similar tech on Mars for over 10 years. Even the Voyager probes from the 1970s were nuclear-powered. But here's the catch, those systems are small. They generate electricity by turning the heat from radioactive decay into just a few watts. Enough for a robot, but nowhere near enough for a moon base. To power an entire lunar settlement, we'll need something much bigger, a full nuclear power station on the moon. And NASA has already been working toward making that a reality. This project is called fission surface power, and it's based on the same nuclear reaction used in power plants here on Earth. It works by splitting atoms from uranium fuel, which releases a large amount of energy in the form of heat. But since there's no water or steam turbines in space like on Earth, we need a different way to turn that heat into electricity. That's where something called a Brighton converter comes in. It's a complex system, but the important thing to know is it works. One benefit of those dark craters on the moon, the ones that never see sunlight, is that they're the perfect spot to place a reactor. Because they stay cold, the reactor won't overheat. However, building a nuclear power source for the moon isn't easy. It has to be compact. NASA says it must weigh less than 6 metric tons and be no larger than a regular car. That's considered tiny for a power plant, but still pretty large when you're launching something into space. One of the leading companies in this field is Rolls-Royce. While most people know them for making luxury cars, they've actually been building nuclear reactors for quite a while, mainly for submarines. Now they're designing small reactors for space. Their latest design aims to generate between 50 and 100 kilowatts of electricity. That's enough to run a few homes or even a small factory. One of these reactors would be enough to power an early moon base, and if we connect a few of them together, we could power an entire moon settlement. So this could be the beginning of our first real base beyond Earth, a launch point for exploring deeper into the solar system. If we can not only survive on the moon, but also grow, build, and expand, then space becomes a place where we can truly live. That's how we take our next big step into the unknown and make it possible to go farther than we've ever gone before.